All right, well, we are going to go over the quiz that you guys took. So this is the quiz on 10.4 through 10.6. I'm going to do both the multiple choice part and the written sections. The quizzes were really good, by the way. The average was a 21 out of 25, which is a B. This is one of the hardest chapters that we do in Algebra 2, so that was great. All right, let's get started. So we're going to find an equation of an ellipse with its center at the origin, and we're given a covertex and a vertex. Now, this is an equation of an ellipse, so when you're taking a multiple choice quiz like this, you can go ahead and cross out the answers you know are not going to be it. And then because an ellipse always has a plus in the middle between those x and y squares. And then the covertex is at 2, 0, so that would be this way, 2, 0. So A is 2. And then the vertex is up here at 0, 6, so B is 6. And so all we do is we're going to need A squared and B squared there, so A squared is 4, and B squared is 36. And so that would be the correct solution on that one. All right, number 2. This one's a little tougher. It's an ellipse, and they all have a plus, so we can't eliminate anything. We are given the foci are at 0 plus or minus 4. So there's a foci, and a covertex over here at plus or minus 2. So our ellipse is going to look like that. It doesn't go through the foci, it goes around it. Well, this A right here is 2, and so I know that A squared is going to be 4, so I can get rid of those 2 right there. So I have x squared over 4 plus y squared over something equals 1. So I got to figure out what that something is. Now a lot of people chose this one because they saw the foci was 4 and they squared it and put it right there, and that's not right. So here's what you want to do. You want to use the formula for foci. C squared equals bigger minus smaller, b squared minus a squared. So c squared is 16, b squared is what we're trying to find, and a squared was 4. So if I add 4 over to that side, I get that b squared is 20, and that's that answer right there. All right, for number 3, this one was the most missed question on the quiz. Only 55% of you guys got this one right. Which is unfortunate, but it's a pretty tough problem. So the center of the ellipse is at negative 1, 3, which means that we're going to write x plus 1, it's always the opposites, and y minus 3. And so all of these have that, so the center's right on all of them, so that doesn't help. All right, now the height is 8. Now what that means is that the entire length is 8. And if the entire length is 8, then that means that this is 4 and that's 4. And the width is 16. And the entire width is 16. That means that that's 8 and that's 8. So looking at this, we have A is 8 and B is 4. And so right here I have to write A squared, which is 64. And here is B squared, which is 16. So which one is that? That's this one right there. All right, question number 4 now. Now we have a hyperbola. So all of these have a minus here, okay? And it says here that the center's at the origin. The foci are at plus or minus 2, okay? And then the vertices are at plus or minus 1. So this hyperbola has to go side to side. And if a hyperbola goes side to side, then that means that x squared is going to be first, which they all have x squared first. Okay. And then y squared equals 1. So let's find out what some things are. A is the distance here, which is 1. And then a squared would be just 1. So we can get rid of those 2. All right, now I have to find out what b squared is, but I'm not given that. I am given c. C is a distance of 2. Distance from center to foci is 2. So c squared is 4. And remember, with these, it's a squared plus b squared. And so if I subtract 1 over to the other side, b squared would be 3. There it is. All right, same type of problem. This time we're at the origin. The foci are at 0 plus or minus 4. Okay, up and down, so foci. And then plus and minus 2 are the vertices. So this one is going up and down, which means y squared is going to be first. And so I can get rid of those two. All right, so b here is 2. It's the distance from the center to your vertices, and that's 2. So b squared is going to be 4, and they both have that, okay? And then c squared, c is the distance from the center to your foci, and c squared is 16. And for hyperbolas, remember it's a squared plus b squared. So a squared plus b squared, and we subtract 4 to the other side, we get 12. There we go. All right, this one right here, we're going to find the vertices of this hyperbola, and this hyperbola, the y is first, so that means that we go up and down a distance of 2, and then we would go, side to side 3, draw the thing, the asymptotes, all this stuff. Okay, but they're just asking for the vertices, so of course I did too much. And the vertices would then be at 0 plus or minus 2. It's not about which one's bigger, because a lot of you guys chose the x going side to side, but when y is first, it opens up and down. All right, let's go to the next page. Here we go. Number 7, now we're going to find the foci of that hyperbola. Now remember, this is the hyperbola that opens up and down, and then the foci would be using the foci equation, a squared plus b squared. So 9 plus 4 is 13. So c would be plus or minus rad 13. And that's going to be up and down because they have to be inside here. So that would be this answer here. The asymptotes, remember the asymptotes are y equals plus or minus rise over run times x. The rise is the b. In this case, b squared is 4, so b is 2. And then a squared is 9, so a is 3. So I would write b over a 2/3 x, which is that one right there. All right, and the last 4, you just had to identify which conic section it is. And for this one, you want to just look at the squared parts. You don't care about anything else, just the squared, okay? And in between the terms is a plus. Well, first of all, there's 2 squared terms, so we know it's not a parabola. Remember, a parabola only has 1 squared term. A hyperbola has a minus in the middle, so it's not a hyperbola. And then we look at the coefficients. Does 3 equal 5? No, it does not. So that means that it's going to be an ellipse. It's going to go a different distance up and down as it does side to side. All right, over here, look at the squared term. There's only 1 here. The only one of these that has 1 squared term is just a parabola. See, because everything has 2 parts to it, kind of. Like an ellipse has a top and a bottom. A circle has a top and a bottom. A hyperbola has a top and a bottom. But a parabola is just one thing, and that's the 1 squared thing. All right, number 11, we have a plus in the middle. There's 2 squared terms. And this time our coefficients are equal to each other, so that's a circle. Boop. All right, number 12, last one. Of course, there's only one answer left that we haven't used, but there's a minus in between these, so it has to be a hyperbola. All right, that was the multiple choice section, and then you had to do some written parts too. So first of all, given the ellipse, we have to graph. So the center of this is at the origin, 0, 0. We're going to go 3 and 3, and then 5 and 5, and the ellipse is that oval-y thing. There we go. The vertices are whichever ones are the farthest away. In this case, our vertices are at 0 plus or minus 5. The covertices are the smaller ones away, so that would be at plus or minus 3, 0. And then the foci, are at c squared equals big number minus small number. C squared equals 16, so c would equal plus or minus 4. And the plus or minus 4 would go up and down because the foci are always on the major axis, the longer axis. So that would be at 0 plus or minus 4. All right, so that one was 5 points. This one was only worth 4. It was harder though, because the center moves. The center is now at 2, -1. So we'll go to 2, -1. the vertices are a distance of 3 left and right. See, this is first, the x is first, doesn't matter which one's bigger. And then 1, 2, 3, 4 up and down. And then you draw that rectangle in. You draw the asymptotes. Neatness does not count here because this looks terrible. All right, there we go. Okay, so then our vertices, and a common mistake that people made on this part was they just said that the vertices were at plus or minus 3, 0. Okay, that's not true. The vertices are going to come from the center. So they're actually at plus or minus 3 from the 2 that you already have, negative 1. And if you want to leave it like that, you can. It's nice to kind of make those into 2 separate points. So 2 plus 3 is 5, and 2 minus 3 is negative 1. And then the foci, same thing. The foci are coming off of the center, not from the origin, but from the center. And the foci would be c squared equals 9 plus 16. So c would equal plus or minus 5. So from the center, left and right, we're going to go a distance of 5. And you can rewrite that. I ran out of room. 7, negative 1, and negative 3, negative 1. Okay? My work, did so good. You guys did great. Hopefully you won't make the same mistakes on the test. All right? Thanks for watching.